Hello and welcome to the Actuarial Research channel, the channel where we break down actuarial exam questions step by step so you can answer them accurately and on time. In this series of videos, we are still going through the Black-Scholes model or the Black-Scholes option pricing formula. And in today's video, we'll be working through 2019, April 2019 exam, question number 4. So I'll just dive right into it. I'll read the question. So the first question is, list the assumptions underlying the Black-Scholes model of option prices. Uh, this is 3 marks. So this is a very easy 3 marks for you. And I did go through the assumptions in the first video. You can check it out if you haven't. So I'll just write my answer here. The first assumption is the price of the underlying asset follows a geometric Brownian motion. The second one is there is no arbitrage opportunity. The third is a constant risk-free rate of interest. To be on the safe side, even though this question is 3 marks, you should give 6 points so that each point is half a mark. So our fourth point is no taxation and transaction costs. Unlimited short selling is unlimited. Short selling is allowed. And the very last point is underlying assets are traded continuously and in infinitely small amounts. And with that, you have your 3 points, a very easy 3 points. On to the next question. Consider a market where the assumptions behind the Black-Scholes model hold. An undividend paying share, so you have to take note of this. It is non-dividend. Paying share is currently priced at 30. A put option, we also have to take note of this. It's a put option and not a call option. Is available on the share with a strike price of 32 and 1 year to expiry. The share has a volatility of 15% and the risk-free rate of interest is 5% per annum. Calculate the fair price of the put option. 4 points. So the best place to calculate this is in Excel, and I will show you just how. So uh, I'm sure by now, if you have gone through the first video we did for the formulas of the Black-Scholes model, you should already have crammed these formulas. And as I advised earlier, it is better if you cram these formulas and know them often rather than having to open your tables during the exams to search. And also note, this is something I noticed when I was doing my exam, that you cannot control find in the tables. You have to scroll down, so you have to know the specific page where the formula is, and that's why I'd advise you to just cram this and know it often. So we'll go to it, and I will structure my Excel to fit all the data that we've been given. So this is how it will look. So the first thing, I'll have the share price, then the strike price, I'll have time, uh, volatility, and then from there interest rate. Correct. I'll just write option here. So we've been told that the share price, an undividend paying share is currently priced at 30. A put option is available on the share with a strike price of 32. and 1 year to expiry, so time is 1 year. The share has a volatility of 15%, correct? And the interest and the risk-free rate of interest of 5% per annum. So again, it's non-dividend, it's a put option, and also we have to uh, look at this interest. Is it continuous or is it discrete? In our case, it's continuous. If it's discrete, we'd have to use especially this next part where we are looking at the present value of the strike price. Because in the formula, remember this part, this is the present value of the strike price, K exponential minus R, and then the time. So the first thing is to calculate this part. So that will be given. And that is why I mentioned that uh, we also have to take note of the risk-free rate of interest, because if it was discrete, we'd use another formula. But here in this case, we'd use the exponential formula. So strike price multiplied by exponential. We are discounting 1 year at a rate of 5%. So that's the strike price, correct? And then what do we need next? From this formula, what we need next is D1 and D2. So we'll go on to calculate D1 and then calculate D2. So I'll just put this on this side so that it's easy for you to follow. The value of D1, that's my numerator divided by my denominator. In my numerator, I'll have ln of, inside the first bracket is ST, the share price, divided by K, the strike price, and then plus, sorry, made a mistake, uh, the plus is outside here, plus the rate of interest, we have 5%, plus 0.5 multiplied by sigma is volatility, and it is volatility squared, so I'll multiply by 15% twice, or you could just raise to power 2, and then multiplied by the time. Time in our case is 1 year. Then for the denominator, we have volatility multiplied by the square root of our time, and time in our case is 1, and that is a value of D1. To calculate the value of D2, again with this formula that is here, which during the exam you will be doing from memory, is D1 less volatility minus square root of time, and that is a value of D2. So when in our question was asking about a put option, right? And this is the formula for the put option. So we'll go on to calculate now the phi of D2. But before that, we just calculate phi of D1, and I'll write that n as n D1 and then as n D2. This is standard normal, a normal distribution, so it's standard normal. So that of D1, where the mean is 0, the variance is 1, and we are doing a cumulative, so we choose 1. Do the same thing, I could just drag, or I will repeat so that you can see. Norm dist, and x is D2, mean 0, standard deviation 1, and cumulative, and I have that. But you see, for a put option, we are not using phi of D1 and phi of D2. We are using phi of negative D1 and phi of negative D2. The reason we did phi of D1 and D2 is because sometimes this is what the examiner usually wants to see. But now I will go on to do the phi of D1 and phi of D2. Same procedure, which is numdist, and then now this value minus d1, and then the same thing, mean 0, standard deviation 1, cumulative, yes, and I could drag or numdist again, just so you see, minus d2 is at mean 0, standard deviation 1, cumulative, yes. And now with that I have calculated all the single values. So now all I have to do is put it together and find the value of the put option. So I'll have here my put option. It is given by k exponential. This is the present value of the strike price, which is that, multiplied by nd2 minus the share price multiplied by nd1. And with that, I get the value of the put option. So I'll go back to my question. The question is calculate the fair price of the put option. So with that, I have my 4 marks. All I have to do now is just copy this and paste it in my answer booklet. And with that, I have my 4 marks. The next part of the question is asking, a call option is available on the same share with a strike price and time to maturity. With the same strike price and time to maturity, calculate the fair price of the call option. So there are two ways you can go about this. You can use the put call parity, or in our same Excel, we could just extend and do for a call option. Again, using this formula, and this is what I'll use since we are practicing on doing Black-Scholes. I'm showing another video when we'll be handling another topic. We'll know how to use a put call parity. So there's no need to worry about that. So for the call option, it is a share. We're using this formula here. So it's the share price multiplied by ND1. And you see, this is the advantage of calculating both ND1 and N minus D1 less present value of the strike price multiplied by ND2. And with that, we have the value of the call option. So we'll just come here. You see, it's only 1 mark. So I'm sure if I could just copy this again and paste it for the examiner, it would be perfectly okay. Or I could just paste the answer using the Black-Scholes formula for a call option. The value of the call option is, I could copy the whole thing. It's only 1 mark, and the 1 mark will be for the answer, and that's my answer. And for the final part, discuss how the option prices would change if the share were dividend paying. So you have to remember, uh, dividend reduces the value of the share. So at all times, it reduces the value of ST. So at this point, we have to look at the payoffs for both the call option and the put option. You remember that the payoff for a European call option is given as this: max ST minus K and 0, correct? And sorry, for a put option, it is given as this: max of K minus ST, comma 0. So for the call option, if it reduces the value of ST, again, we say that dividend reduces the value of the share. If dividend reduces the value of ST, then this means So we'll write here dividend reduces the value of the share. So what implication does this have? This would mean a lower option, a lower call option value. Since again, if you are the holder of a call option, you do not receive this dividend. For a put option, it is vice versa. If this value reduces, then it means the value of the put option increases. Again, the value of the put option increases. And also you have to remember, if you are the holder of a put option, it means you hold the share and you are receiving dividend. And with that, we have our 10 marks. This is the Actuarial Raster channel. Subscribe as we tackle more actuarial exam questions together. See you in the next video.